All right. Grab a pen here. Things. Okay, if you would please find your warm up for today. If you do not have the warm up, it looks like it is located in the textbook on page 662. All right, so that's where our warm up is located, or you can find it online posted for you. Well, let's take a look at this. So, Fiona and Rachel want to determine the most popular lunch choice in the school cafeteria among seventh grade students. They decide to collect data from a sample of the seventh grade population at school. Fiona surveys 20 seventh grade students that are in line at the cafeteria, and Fiona's results are shown. It looks like the first one we have checkered, it's grilled cheese. The second choice here looks like it's chicken. Third is other. Six said, oh, so one said this, three said other, two said chicken, six said hamburger, and then eight said pizza. Okay. Rachel surveys 20 seventh grade students whose student ID ends with 9. She saw that 6 of them said others, 1 person said they were getting chicken, 6 people said pizza, 5 people said hamburger, and 2 people said grilled cheese. Which sample is the better representation of 7th grade students? Okay. You can argue this in both ways. I would sit there and say, if we look at Fiona, so Fiona went and she surveyed 20 students that are in line at the cafeteria. We do not know whether or not that she just picked 20 random students, whether she picked 20 students that are in the front line. We do not know exactly how she chose her 20 students. Whereas Rachel surveyed 27 grade students whose student ID number ends with 9. So she went and found all the different student IDs, and she randomly chose not 20 students with the student ID ending with number 9. So for me in this instance, I would say Rachel has a better, I did not spell that right, better random sample survey. Okay. You can argue this both ways because there's not enough information given to us to be able to fully decide. You can make a lot of inferences between the two statements and between the two things that are being discussed. All right, but let's move on. So if you would, while our minds are now thinking on this, let's look over at circle graphs. So study the circle graphs, think about how they were made. Use what you know about angle measures, circles, and percentages to consider the following. 1, how do the percentages correspond to the size of each wedge? What should all the percentages add up to and why? And why is it helpful for percentage data to be represented in a circle graph as opposed to another type of graphs? Okay. Then use the graphs to answer the questions below. All right, so I've got my first graph here, owner solutions for bad breath in dogs. Looks like I have 54% say toothpaste, 23% say mouthwash, 7% say dental floss. Oh no, wait. 23% say other, 7% say dental floss, and then 16% say mouthwash. And then owner solutions of bad breath in cats. 53% say toothpaste, 9% say others, 24% say dental, and then 14% say mouthwash. All right. So the first question that it was sitting here having us do is looking at the percentages in each size of the wedge. Well, if we look at this wedge right here, we know that directly straight down, it's going to be about 50%. So knowing the percentage and knowing the size of the wedge, I know that I'm a little over 50%. And I know that each of these percentages here, they should all add to 100%. Okay, so each graph should add up to 100%. So let's look at this. Out of 200 dogs, how many would you predict using mouthwash for their dog's bad breath? All right, so we can do this 2 ways. You can either choose your part over your whole is equal to your percent over 100. okay, and solve your percentage from there. Or you can use your equation of part is equal to percent times 100, where percent is written as a decimal. Okay, I prefer to use the equation. You're more than welcome to use the ratio because I know my total is 200. So I'm going to say part is equal to percent times the whole. Well, the whole is equal to 200. My percent, well, it says, how would you predict using mouthwash in dogs? So dogs, mouthwash looks like it's going sideways. So that's looking at 16%, which in decimal form, it's going to be 0.16. So part is equal to 0.16 times 200. All right, 200 times 0.16. Well, 0, 0, 6, and 2 is 12. Placeholder 0, 0, 1, and 2 is 2. Looks like I have 3,200, but I have 2 decimal places. So part is equal to 32 people. So out of 200 dogs, 32 dogs use mouthwash for bad breath. Okay. All right. If 250 cats and 250 dogs were included in the circle graphs, about how many more cats used dental floss than dogs? All right. So let's see here. Dental floss looks like it's my little pieces here, and they're at 24%. So let's do cat. My percentage is 0.24. Dog. My percentage is 7, so 0.07. My whole is 250. Whole is equal to 250. Okay, so part is equal to 0.07 times 250. So I'm going to do this over here. 250 times 0.07. You guys can still see. 0, 7 times 5 is 35. 14, 15, 16, 17. And then I have 2 placeholders. Well, let me do this. 0, 1, 2, 3. And then I have 1750. I have 2 placeholders. So out of my dogs, it should be 17.5 dogs. My cats is 0.24 times 250. So 250 times 0.24. 20, 4 times 2 is 8, plus 2 more is 10. Placeholder 0, 2 times 5 is 10, 2 times 2 is 4, plus 1 more is 5. 6000, place decimal points, so point. So my part is equal to 60. And it wants to know how many more cats than dogs. So I'm going to do 60 minus 17.50. I'm going to have to borrow 9, 10, 0, 5, 7, 8, 9, 2, 4. So roughly 42.5 or 43 more cats. Because can you really have half of a cat? No. So about 43 more cats than dogs use dental floss. All right. And then number 3, how might companies use this graph? What type of companies might find these graphs useful? All right. So let's go back up here. Owner solutions for bad breath for dogs, owner solutions for bad breath in cats. How might certain companies use this? I would think that many different companies could use this. This all depends on your personal preferences. I would think that veterinarians, so vets, would look into this as suggestions to their clients. Another company that might use this, or how companies could use this graph, is that the company who makes toothpaste for dogs/cats could advertise that more than half their clients choose them over other brands. Okay, we do not know that if it's a specific brand, but all of this right here is what I'm trying to say is that a certain company, so say it's one company that makes the toothpaste for dogs and cats, they could look at these two circle graphs that we have up here and knowing that it's 54 and 53, so just over half, they can turn around and say that more than half, which is still true, their clients choose them over other brands, as in they choose to use toothpaste for solution for bad breath in their dog or cat versus the dental floss or mouthwash and whatnot for each different animal. Okay. All right. So let's look over here. We got Krista sets up a monthly budget as represented by the circle graph. Decide if each conclusion is supported by the circle graph. All right. So looks like we do not have any percentages, but we can sit here and make a couple of inferences. If we were to split this circle graph in half, kind of like right down here, I know that each half is 50%. And then if I were to split this into quarters, okay, each section here is worth 25%. Okay, because all 425% added up together equals up to 100%. All right, doing it this way can help us answer these questions. So it says, Krista spends 50% of her income on housing and food. So housing and food, if we were to take this, and even if we turn our circle graph and we split it straight down the middle right here, we can see that it is this. Is it supported by the graph? And we're going to say yes, it is supported by the graph, because even if we looked at this right here, I have 25% in housing. I know that this section right here is 25% between housing and car. I can assume that this extra 25%, there is another 15% on top of that. 25 and 15. So I have what, 40%? And then I'm between food and entertainment. So food could be another 10%, where entertainment can be about 15. And with entertainment being at 10%, 40 plus 10 should equal up to 50%. Okay, so that's my explanation there. All right, or you can just sit there and draw your other line to show halfway. All right, Krista spends 25% of her income on car and utilities. Okay, on car and utilities. So let me get another color. So let's see, if we sit there and split this here in half, let me go this way. That means we're going to go roughly this way. So even if I look at it, even if I go from here to here, and I'm told 25% of car and utilities, that right there looks a little bit more than 25%. So my answer is going to be no. Both wedges show more. Okay, both wedges show more. All right, Krista spends 50% of her income on housing and utilities. So let's see here. Let me get another sheet. So I kind of have drawn all over this one. All right, here we go. So it looks like we're wanting to know about housing and utilities, and we're saying she spends 50% of her income on housing and utilities. Well, if I look at this, housing shows a little bit more than 25%. So we're going to say about, 30, 40%. And utilities, well, utilities looks like it's about the same size as my food wedge. And we know that housing and food makes up to be 100%. So I can sit there and say, yes, that my graph does support this statement. Okay. And then the very last one, Krista spends 25% of her income on food and entertainment. Well, if we go back to this graph here, remember when I split my graph originally down the middle and then quartered it up, and I have food and entertainment, and this does support my graph of saying, yes, it does support that it could equal up to 25%. Okay. All right. Letter C. Use the graphs to determine whether each statement below is true. For each statement that it is not true, explain how you would change the statement to make it a true statement. All right, so daily food consumption. So my first graph is children ages 2 through 18 years. It looks like their first one is their main food consumption is 67% for home, 4% for restaurant, 11% for fast food, 9% for school, and then 9% for other. Versus 60 and older, it is 79% at home, 8% at restaurants, 4% at fast food, none for school, and then 9% for others. All right, so it looks like these are true or false statements. Adults ages 60 years and older eat twice as many calories at restaurants as do children ages 2 through 18. Okay, well, let's go back up here and look at this. Well, restaurants for children, it is 4% versus restaurants for adults is 8%. So it's saying that 60 years and older, they eat twice as many at restaurants than children do. Is 8 2 times more than 4? And the answer is yes. So that is a true statement. Okay. I'm going to leave my circle graph here because I have a couple of questions on the back. All right. So my next question is adults ages 60 years and older eat more than a quarter. So let's see, more than 1/4. So that would be 25% of their daily calories at locations that are not their home. Okay, so let's take a look at this, our graph here. If you think about it, our graph can be split up into quarters. Okay, I can take my graph and I can split it straight down here to have 50%, and then I can split it straight here to have 25% in each section. So I have to have more than 1/4, so more than 25% of my calories are eaten at locations that are not in their home. Okay, so will they have 9%? Okay, 9% for other, 0% for school, 4% for fast food, and they have 8% for restaurant. All of these numbers here should add up to be 25%. If it would be more than 1/4, well, let's look. 9 plus 8 is 17. And then 17 plus 4, let's see, 4 plus 7 is 11. So I have 21% is the calories eaten at other locations. So is this true or false? And this would be false. And if false, change the statement to make it true. And then what I would say and how I would change the statement, I'm going to write it down here, is that adults ages 60 years and older eat less than 1/4 of their calories at locations that are not at their homes. So the only thing I changed in that statement was the word more than to say less than 1/4, because we just did the math to prove that it is less than 1/4. All right, let me back out here. Okay, so number 3, adult ages, I'm going inwards, I need to go outwards. There we go. Adult ages more than 60 years or older eat more calories at school than children. Okay, wait, let me phrase that. Adults ages 60 years and older eat more calories at school than do children ages 2 to 18. Well, is this statement true? The answer should be no. So if we zoom all the way in here, okay, we can look at this. School, I have 0% for school versus my kids 2 to 18, I have 9%. So the statement to this is false, okay? And what we're going to say is that if not, change the statement to make it true. So we're going to say children ages 2 to 18 eat more calories at school than adults 60 years and older. Okay, that's how we can change the statement to make it true. All right, and then the last one, children's ages 2 to 18 eat more than 1/3 of their calories at home. Okay, more than 1/3 of their calories at home. So if we look over here at our graph, we know that 60% or 67% is our children are eating their calories at home. Even if we sit here and split it up to be 1/2, I know that it's more than 50% and it's just over 2/3. Okay, so 1/3, if you think of this in a decimal wise, it's 0.3333. It's 0.3 repeating. But if we move our decimal 2 places to the right, 1/3 is 33.3 repeating percent. Okay, where 2/3 is about 66% or 67 rounded up. So it's saying that children eat more than 1/3 of their calories at home. And this statement is true. They do eat more than 1/3. They eat 67%. So more than 1/2 of their servings of calories come from food at home. Okay. If you guys have any questions, please let us know.